From the age of 10, Jerry Minter started engineering his own radio. He went on to develop and manufacture rugged, reliable signal generators and connectors for military and civilian purposes, making major contributions to the nation and to engineering science. He is also founding father of the IEEE North Jersey section. During World War II, Measurements Corporation, co-owned by Mr. Minter, helped win the war by supplying the military with signal and post generators and noise meters. The Army used the Model 75 generator in radar systems at Fort Monmouth. The Army Air Corps used the Model 84 for signal calibration systems. A UHF signal generator was used in countermeasures that helped win the Battle of Britain.
During the war, we had up to 100 people working for us, making signal generators. Signal generator is a radio transmitter used for testing receivers. And there were special ones for radar. Radar was a new thing in those days. It required a special kind of test gear. It required a signal that could be turned off and on, like television. Television was just starting. It really wasn't well known during the war. But the principles that are used in television were used widely in the signal generators that we made for testing radar. Radar, of course, was a big factor in the war.
But let's step back and tell you about Jerry Minter's early days as an electronics pioneer. His first job earned him $15 a week at Boonton Radio Corporation in New Jersey. He developed an inexpensive, reliable Q meter to measure figure of merit in capacitor coils. It was 1934. Milk was 10 cents a bottle and gas was 12 cents a gallon. Jerry was completing graduate work at MIT. His thesis earned him the first of 26 patents for a low phase shift wideband filter used in early Armstrong broadcast transmitters. From Boonton, Jerry worked at RFL and Ferris Corporation, then started Measurements Corporation. The company developed highly reliable, sensitive grid dip meters for precise frequency measurement and supplied a full 10% of the test equipment load in the United States.
You can measure a frequency of something just by putting it close to it and coupling it in. So you can measure what's happening on a bench dynamically and see if you made a mistake in something, the frequency will be off. Now, this, of course, we made in very large quantities. We actually had to, these are the coils that plug in. The little coils plug in to change frequency ranges, to go very low frequency to very high frequency.
The Edison Company bought Measurements Corporation in 1953, and Minter turned his full attention to Components Corporation and advancements in precision edge connectors.
The connectors that were being manufactured were not too good from the standpoint of reliability, and they were big physically. So we made a much smaller unit that could be put into very, very small units, very, very tiny unit. And we made them out of beryllium copper that we heat treated, as I said before. So it lasted indefinitely. The springs would last. Many of the connectors were not even heat treated. They made them out of spring brass. So you want a few connections and they start to lose contact. Tube sockets, for example, they were all just ordinary material. But you only plug a tube in once or twice, so you get away with that. But if you plug a tube in several times, you start to damage the contacts, in those days anyway. So we made better contacts so that things were more reliable when you plugged them in. And we've had all the major costs we got, of course, during the war were through our contacts through the military, people making military gear. And there are many companies that are in that business. IT&T was a big one.
In the 1960s, Minter's company built miniature high-voltage power supplies used in NASA probes and at the Goddard Space Flight Center. Components Corporation supplied high-reliability edgeboard connectors for Sperry Rand's early UNIVAC 1108 computer, DC-10 airplanes, and space exploration. General Dynamics, now Hughes, employed the Digiclip connector in the Navy's SM-1 missile. Jerry also pioneered the development of VCRs for use in hospitals.
High voltage is required for all our big projection systems, of course, to get high voltage. But we have high voltage in even the medical field. It can be used for sterilization. There's a lot of things that are being done with high voltage today. When we say high, it's relatively high. Of course, it's not thousands of volts, but hundreds of volts per inch maybe. So you want to be able to measure voltage without changing what you're measuring, which means you have to have a very sensitive meter to do it. So we helped to develop sensitive voltmeters for measuring field strength. In fact, that's how we got in the connector business. We were supplying these field strength meters to the Goddard Space Flight Center and others, and that led us in the business of making the connectors. But we made a lot of field strength meters. It's just a wideband radio receiver that's calibrated. And it was calibrated in volts and microvolts. And we made various adapters to hook it up to various. For example, an automobile, you want to check voltage on a spark plug or where it's going with the spark plug. You want to reduce ignition system interference. We spent a lot of time with the automotive people on ignition noise suppression and control of it and instrumentation for it. And of course, there was some of that in the military field for the aircraft. They have some specialized interference problems in airplanes due to interference from the aircraft systems. And we helped some of the aircraft people with test gear.
The electronics industry was booming in New Jersey. Engineers from Bell Labs, ITT, and Westinghouse opened their auditoriums for meetings of the Institute of Radio Engineers, the IRE. Jerry was active in the IRE, starting the North Jersey section. The IRE merged with the American Institute of Electrical Engineers in 1963 to form the IEEE. 100 members would attend meetings, and a dizzying array of research papers were published in IEEE journals. This visibility helped expand the North Jersey section. Color TV was the craze, and Jerry worked closely with RCA, making signal generators to test TV receivers. Dumont Laboratories was more advanced than RCA in color and pioneered the first TV cameras.
We actually had Dumont sponsor several things, technical papers on what they were doing in the video equipment. They actually pioneered the TV cameras. They pioneered the first. RCA actually had to bow down to Dumont because RCA didn't know as much about building these things as Dumont did. So they actually worked with RCA in the very beginning. And we had some technical papers on the problems. Color created all kinds of problems. As soon as you went to color, you had much more complication than you ever had with black and white. And Dumont was very helpful in color because they made the first color equipment.
Jerry Mitter's recent engineering activities hark back to early work on small aircraft receivers. He's had a lifelong love of flying and was active in the Civil Air Patrol. He often used his own small plane to fly search and rescue missions. Of his 26 patents, the last 6 are for a passive collision warning system, enabling small planes to avoid mid-air crashes.
Anyone that's at your altitude, flying an airplane, I can detect them out to quite a few miles away automatically if they're at your relative altitude by measuring differential time of arrival of 2 closely spaced antennas. I have 6 patents on that, just issued about a couple of years ago, and I'm trying to get a licensee now to produce this for use in every airplane. It'll flash a red light for you, or put a signal in your headphones, stereo headphones. I have 6 patents. 5 of them are how it tells the pilot where something is out there. In front of you, behind you, it's a complete area measured.
Jerry also has a good sense of humor, especially where it concerns stories about Thomas Edison and his son Charles, who was governor of New Jersey. Jerry had dinner at Edison's West Orange Laboratories to finalize the sale of Measurements Corporation to the Edison Company. He also had a long conversation with Charles at his suite in the Waldorf Astoria, mainly about Charles' close relationship to Henry Ford. At the same time, Jerry heard stories about Thomas Edison through business contacts.
I got a funny story that I can't remember the fellow that was representing at the time, but the guy from Edison, we were standing out in front of the plant one day, and he said, "I got to tell you a story." So we had a fire here one time, many years ago, and we had all our stuff inside, our standards in the lab fire, bringing the standards out so they wouldn't burn. And he said the governor himself was here. You know, he was not governor then; he was active. He was here, and he was watching everything going on from the fire, and he says, "Call your mothers, come out and see this fire. Call your mother." He got a big, just like kid, he's out there watching the fire.
For Jerry Minter, accolades and awards abound, including a Fellow Award from the IEEE, the Armstrong Medal from the Radio Club of America, of which he was president, and a founding member and past president of the Audio Engineering Society. His record speaks volumes about his commitment to excellence, constant drive for improvement, and service to his country and the IEEE. We are proud to honor him as the first member to be videotaped for the IEEE's History Center Oral History program.